separation anxiety. Let me just quickly ask, this could go one of two ways. This could go poorly or it could go well. I have some slide deck and I have a demo application. I plan to do a big code review with you guys, which could be crazy and turn out horribly, or it could go fantastically. I can focus on the slides, I can focus on the demo code. Who here wants to see the demo code more than the slides? That's maybe 2/3. All right, everybody else, you okay if I do that? So I'm going to go through some slides quickly to set up some talking points. I'll also mention that I wrote the slides to encourage interaction with you. So if I say something that makes you mad, just tell me. I'm trying to. Let's start. So let's engage right away. What concept do you value most in the context of software development? I would like to hear a few thoughts quickly. Maintainability. Readability.
Modularity.
Modularity, we're spelling some more.
Testability.
Testability, nice. Scalability, all right. Cool.
Meets the requirements.
What was that?
Meets the requirements.
Meets the requirements. As a value. All right. So I'm going to kind of the base of the whole thing here. I'm going to say that to me the most important idea is problem decomposition. And the other half of that conversation is how do you compose a solution. And that solution composition is where we address all of these s'mores ideas that we were talking about. This was maybe the impetus for the presentation. This is a blog post by James McNally. I asked him if I could do this, and he was okay with it. Can you guys read that at all? No. This is the part I care about. Can you read that? So after GDEFCON, James posted this in the little blurb that says, CLA Summits are often places to pontificate about architecture and design, but that's of no interest to someone getting going with LabVIEW or working on an established framework with challenges that they have to meet quickly. I disagree with this. How do you guys feel? Disagree? Hands up. James is a great guy, super nice guy. Very smart guy. If you haven't met him and you're at week and he's there, you should. So why do I disagree with this? Well, let me see if I can explain it through a few slides. So working code is not enough, and appeal to authority here, Uncle Bob. Let's talk about how we as developers can kind of be broken down into two very broad categories. So if we think about ways of approaching software, I'm going to say that we can talk about it as you're either a tactical programmer or a strategic programmer. Now, tactical programmers, they're the people who are usually seen by heroes, as heroes by management, because they're given a problem with the crazy deadline and they get a solution implemented and everybody claps. But then they walk away and they have this wake of destruction, right? So they move fast, they break things with heroes, and they generate a very interesting kind of technical debt. On the other side of the equation, we have this idea of strategic programming. I'm going to say that a strategic programmer focuses on problem decomposition, right? I just do that by report out there. And they do that by thinking about separation of concerns. Maybe they place an emphasis on continuous investment in their infrastructure, their test code, a lot of refactoring. And they also accrue technical debt, but I think they do it in a different way, and that's very important. So I never really liked the idea of technical debt because it just sounds like something that happens to everybody and it's not your fault. I think it might be better to talk about it in two different ways, tactical debt and strategic debt. This is kind of an extension of the thing I did 2 years ago on Tell Everybody Hacks, where I talked about technical debt and using it as a strategy for refactoring. So if we break technical debt up into quadrants, do it like this and say, type of technical debt, you can be reckless and deliberate. You're saying, I'm a tactical programmer. I don't have time, I have to get this done, I'm just going to make it happen. Reckless and accidental, you're making decisions because you don't know any better. Deliberate and prudent, that's you saying, I don't know everything I know about the system, I'm going to go out and try some things. I expect them to have to go and refactor these things, so I'm going to accrue that debt, I'm doing it on purpose. And then prudent and accidental, you don't know what you don't know. Sometimes you just have to start. But taking that mindset also involves being honest with yourself and your customer, saying, I'm going to accrue some debt here because I have to. I have to learn about the problem so I can find the best solution. And that implies I'm going to fix the problems that I create later. The customer needs to be okay with that, so they're going to pay you for it. So some examples of reckless and deliberate design, reckless and accidental, certain sewing you up with a tool inside you. This is an interesting story, prudent and accidental. They designed this building so that it was concave and it would actually focus the sunlight and melt cars. Yeah, they did it twice. I think it was one in Las Vegas and one in Europe somewhere. But they went back and they fixed it. They didn't do it on purpose. They accrued that debt. They addressed that debt. And then this is cool, genetic algorithms. How I think NASA used genetic algorithms to design this antenna, where they said, I don't know what this is going to do, let's try it. And they ended up creating this antenna that was more efficient than I guess people could design. Let's get that. So if we try to break this down, I'm going to say the things on the right are strategic debt. These are the kind of debt that a strategic programmer is going to say, I need to accrue this debt, and I plan to pay it back. I'm going to do this for a specific reason, and I'm going to make sure that my customer understands why I'm doing it, and everybody knows that at the tail end, I'm going to go and fix these things. On the left is what I'm going to call tactical debt, where you're doing it because you want to move fast and break things, or you're doing it because you don't know any better, and you're not trying to get any better. I need tactical tornadoes. So later on, I'll show you a book. But tactical tornadoes go through and destroy stuff. Anybody in the room want to volunteer as being a tactical programmer?
I've been in the past.
In the past.
The distant past.
And I fully expected people to say, you're wrong. You can totally be tactical and it makes sense. Anybody want to tell me that? I'll tell myself that. Yeah, go ahead.
So you have a multi-million-dollar project and the company senior says, hey, we've got to get this done. We put together a team to get it done, or you all lose your job.
Yeah.
Now, if they're good people and they allow you to go back and fix it later, we understand.
That's strategic. If they allow you to go back to no, that is, right? As long as they understand the trade-off. So here's the punchline. To get your CLA, you have to be tactical for 4 hours. Now, what I'm really saying here is the CLA exam doesn't mean as much as I think we all think it does. Because, Alan.
So, you actually trying to develop a previous question.
Yep.
Half the time for 4 hours.
Yep.
You go into that exam without a strategic plan, you'll fail. And I
Yeah.
think that's, so there's time to be, a little bit of exception with the kind of strategic, because I think there is time for those folks to do and maybe with the general Senate with parent. There's time to be tactical, and we as architects need to strategically prepare for that time.
Yep. Does everybody hear what Alan?
No. You better plan, you better have stuff in a block and take it.
Let me just repeat that for everybody. So Alan Smith was saying, as an example here, yes, when you're in the room for 4 hours, you're tactical because you're moving fast, trying to get this thing done. But you have to go into it with a plan. You have to go into it knowing how to solve the problem. So you need to have that strategic base. And I think you said this, some of you didn't say this, that our job as architects is to provide that strategic base for other people who may not be architects to act tactically, or ourselves, exactly. And that's what I should have said before I switched slides, because that's exactly the point I wanted to make. Thank you, Alan.
The real world and analog to this is we have now put the machine in front of the customer, we have personnel on site, and we can install and get it running. And you're absolutely in front of people who are not doing it. And I hate this with passion. We're absolutely in front of people who are not going to tolerate you going into it.
We cannot hear him say.
I know.
Feel free to paraphrase.
You know, just say it. So go ahead and say it again real quick.
Oh, okay.
So what I was saying is that this is an exam, and the exam is necessarily artificial. The real world analog to this is, you are putting the machine in front of the customer today, and you are turning it on, and you know that there's some stuff that's not going to go right. And you are in front of people who, for a variety of political and business reasons, are not going to tolerate you withdrawing for 4 or 8 hours to make a good plan. And we know that's coming. Anybody who's done even one project to completion knows that time is going to happen. And so being properly tactical, which is I think where you're going, is to be prepared for that, to go in do it, okay, and then you go back to the customer and you say, yeah, we learned some stuff we didn't know, and now we have to fix it right, and we simply have to do that, but we demonstrated what we need to do.
Oh yeah, no, there's always unknowns. There's no way around that. If you, in my opinion, if from the start you take a strategic approach and you try to compose your solution, I'm going to preach separation of concerns here, that when you're in front of your customer for those hours trying to fix that, changing your software should be easy, and it should be easy to do without breaking other components. You should be able to go and address the issue area and trust that you're not going to impact other parts of the system. So that strategic base allows you to be tactical in front of the customer. Another way to talk about being tactical and why it's valuable is just practically, as a company, we work and we sometimes embed on other teams, and we bring our way of writing software to those teams, and we plug their members into our team. These are people who have really zero experience with LabVIEW, or at least proper development. A lot of times they're just engineers that have been told, here, go make this work, which is where we all started. And so another point I want to make is there are places within a strategically laid out application that you can go and say, here's your little section. I want you to go and program this. Here's just a little model I want you to implement. Here's a part of the view I want you to write. And it's okay, it's more okay to be tactical inside that box because I've drawn that box for you. And that's actually the best way for them to learn the value of programming this way. They have to do it that way. You can't go read a book about it. You need to actually interact with people and make a real application. So this is kind of a joke, but also a point. So I think that we can boil all this down to one principle. I think this is the motivating factor behind good software development. It's more important to reduce the effort of maintenance than it is to reduce the effort of implementation. And the effort of maintenance is proportional to the complexity of the system. I think you can probably derive a lot of the software principles out of these two sentences if you try it. If you write good software, the majority of the time that system's going to be living in maintenance. If you work iteratively, as soon as you deliver your first bit of code to your customer, you're now in maintenance, even though you're still doing development. Planning for change to make maintenance easier might cost more upfront, but it easily pays for itself on the tail end or even in the middle of the project. I think that's a really important point that may or may not be lost.
John, what about doing the and on that first one? Like, if you can actually make it easier to reduce the effort of implementation and at the same time make it more maintainable. Like,
Yeah, sure.
I think even more important than either two is actually achieving both.
Yeah, no, exactly. And this kind of leads to, is anyone here in Chris Stryker's presentation yesterday about frameworks? Yeah, so when you put a slide up about drawing a line in the sand between your framework and your customer's application-specific code. If you are using frameworks, you've developed frameworks that function the way frameworks should, you get that and, right? You get that starting point to solve a lot of the complexity with applying these principles to your code, where you end up writing primarily context-specific code for your customer. So yes, there could be an and there, but you have to earn it. Jim?
What about estimating the total need for maintenance of the system? Because sometimes we write code and the deliverable is a data file. Sometimes the deliverable is a data file and the code is just a means to that end so that you can present a report and people can make a design decision.
Yeah.
In those cases, like my strategy is to get a presentation chart and my tactics are with this code unit.
Yeah. So I will tell you, I'm going to show you some code, and you guys might think I'm insane, but I'm going to show you our technology stack, and this is a stack that I've used on projects that were 100 hours and projects that were multiple thousands of hours. I use the same tech stack. I do that because it's important for me and the people that I work with on the customers and within the company to get better at what we do. And the more we use our tools, the better we get at separating out the concerns and decomposing the problems, the better we get at doing it in the future. So I like to use this tech stack even for what most people would call simple problems. I know what you're saying. Like you're saying, you want to do a proof of concept and you just want to bang something out. If you think that proof of concept could evolve into something usable, I would still try to be strategic in how I develop it. Did that answer your question?
Yeah, and I think if it only takes you a fraction of the amount of time to pull in the existing framework that you know how to use, then that's reasonable.
Yep.
Yeah.
Yeah, but that's, I expected that to be the main point of contention, is I'm advocating for leveraging my frameworks for everything. People are running on the same way. Chris?
So I take a little bit of issue with the second point. Effort of maintenance is proportional to the complexity of the system. There are some very complex frameworks out there, so I don't know where you're drawing the line with the system itself. Because you can use very complex tools, but it's very easy to maintain if it's architected appropriately.
Yeah, so in my mind, the tool, the framework provides an API that you can treat it like a black box to interact with the API. I don't need to know about the complexities, but hidden for me, that's okay. So I'm talking about the application, like the business logic that you write to make the system act like a system, the resource layers that you write to interact with the hardware the system has to talk to. That's the complexity I'm talking about.
I think that's a point that's often lost in this conversation, is you can use very complex things if they are already solid.
Yep, precisely. When people say, I can't use the active kernel for this because it's overkill, it drives me nuts. Any other thoughts on this slide? I do have some code I want to show you. Another field of authority, separation of concerns, even if not perfectly possible. So the only available technique for effective ordering of one's thoughts. So what I'm going to say is separation of concerns is the right strategy for problem decomposition and then solution composition. And these get wordy because I didn't trust myself to say this as well as it was typed. The goal is not to reduce the system into its indivisible parts, but to organize the system into elements of non-repeating sets of cohesive responsibilities. A lot of people, I think, when they think of separation of concerns, means they want to make everything a class. I don't think that's what it means. The overall goal of separation of concerns is to establish a well-organized system where each part fulfills a meaningful and intuitive role while maximizing its ability to adapt to change. That's important. Being able to adapt to change gives you that maintainability that we're talking about. The values of separation of concerns. So if we broke it down into 4 values, why we want to even do this. Number 1, lack of duplication and singularity of purpose of components makes the system easier to maintain, so there's maintainability. The system as a whole becomes more stable as a byproduct of increased maintainability, so you get stability. Strategies required to ensure each component only concerns itself with a single set of cohesive responsibilities result in extension points. So now it's extendable. The decoupling that results from the cohesiveness of components makes it reusable. So we're kind of spelling out s'mores here without really saying the word s'mores. And you could also extrapolate that to different solid principles, I think. I think separation of concerns is a core thing that we should all be trying to do. Anyone disagree?
That's the single responsibility principle.
Yeah, exactly. Yeah, I think you can, through these ideas, you can start to derive a lot of the
Yeah, you
solid
can word it in different ways,
Yep.
it means the same thing.
Yep. My goal was to not have solid on a single slide. And I hope that somebody would say, you're just talking about solid.
Well, I will be talking about it for the next hour.
Yeah. So how do we do separation of concerns? Well, it's simple, right, when you show it like this. You want to try to decompose your problem down into these 3 different layers. And when I say layer, I don't mean they literally like stack on each other, but this is a way to think about it. Your presentation layer, your business layer, and your resource layer. Your presentation layer, everyone knows that's the user interface, how the person interacts with your software. The business layer, when I say business layer, when I say business rules, I mean the logic that makes a set of hardware act like the system that your customers want. That's what I mean when I say that. The resource layer is the hardware that the business layer interacts with to make the system do things. And then off to the right, you end up with utilities. Think of something like logging. Think of something maybe like a message bus. And those are cross-cutting concerns that you end up putting in different layers of your application. And as you start to break this problem down into these different sections, you start to create components at these different levels. Extending concerns, I'm going to kind of blow through these so I can put code. So you can extend the resource layer through extension or substitution. Think hardware abstraction layer, message abstraction layer. How do we manage dependencies between these different concerns? I'm going to show you how I do it, and that is very heavily based on our technology stack. So I'm going to try to explain our technology stack while I'm doing this. That's where it's going to get interesting. But essentially, this is what it looks like. A presentation layer that has a message bus that we're able to abstract communication from the business layer. So we are able to cut that tie, that coupling between those two layers using an abstract implementation of a message bus. The resource layer, that's where you traditionally see your hardware abstraction or your message abstraction. So we end up with components. We'll have it with components, and those components are abstracted through an API, and then the business layer depends on that abstract API. Does that make sense? Any questions on that? It's really high level. I don't know if you believe me or not. I'm going to show you some code that does this. API design. This is really interesting to me. So if you think about an API for a component, for a class, whatever it is, this is a cool way to think about it. The green on top is the interface. That's what you're exposing to your customer. So Chris just kind of talks towards, where's the complexity? The complexity is blue, the functionality, how it does what it does. The value of your API can kind of be summed up to the right. A shallow component, which has a broad API that doesn't deliver much functionality, is not very valuable. You're essentially saying, I want you to spend the cognitive cost or the time cost to go and learn my API, but I'm not going to give you much value for it. You probably could have solved the problem similarly yourself. Now I'm going to contradict myself and say that sometimes it makes a lot of sense to have a shallow component. We have a lookup table component as a G package. It's a very simple wrapper around a variant attribute table. It is a shallow component because it does a simple thing, but we depend on it everywhere, and you have to start somewhere. So I think in that case, it's okay to have a shallow component. But you could,
It's not shallow. It's the effort you put in it is shallow.
yeah,
But the variant attributes.
yeah, no, that's a good point. That's a good
Everybody
point.
did it for you.
They did it for us. Yeah, all the arguments are not. That's a good point. The deep component has a narrower API, so there's fewer things you have to know to interact with it, but it delivers a lot of value. I think of the TCP palette in LabVIEW as being a deep component. It does a lot of things I don't want to know about, and it's simple to interact with, just a few function calls. So in these terms, we can talk about the cost of using APIs. So since we like quadrants, we can make a quadrant for API design. API that's narrow and deep, beautiful, that's what we want. Broad and deep, I find that it's usable, and in fact, I'll show you one that's broad and deep that I like. If it becomes broad and shallow, then at what point is it of any use to you? If it's very wide, it doesn't do much. There's a lot of function calls with little value. And then if it's narrow and shallow, it might be useless or it might not be. I probably shouldn't put useless there because in certain situations, you might just want that. So if you find that all of your APIs are designed to be narrow and shallow, that might be a design smell. So yeah, there's the cost. Little plug for GPM. All of our tools, all of our usable components are G packages. The demo I'm going to show you, I made it into a G package, so you can just go pull the G package, and you'll get all the dependencies you need to run the demo. You can go play with it. So separation concern strategy, we have these three layers we talked about. So for presentation layer, model view controller, model view view model, I'm going to show you MBA, which is our internal tool. It's a separation of concerns pattern built on top of the active framework as an extension. That's one of our frameworks that we leverage. For the resource layer is your traditional hardware abstraction or message abstraction that everybody talks about all the time and does. This is the one that gets abused the most, I think. You get a lot of unnecessary hardware abstraction just for the sake of abstraction. And then the business layer. In my mind, this is the hardest thing to change. I think it's super easy to extend and change the resource and the UI. But changing the business layer, in my experience, has been the biggest point of, let's see, if you don't do that well, that can cost your customer the most money to change, which is important. Let me tell you a story. You guys probably can't read that, but you can take it. About a year ago, I got this email at 3 in the morning from a customer I was working with. This is the owner of the company, who I never interacted with. my main point of contact was the chief technology officer. And I just met with the CTO 2 or 3 days prior, and everything was good. I had a list of things that needed to change. There are things at the resource layer for extension, and there are things at the UI layer for changing what the UI looks like. This email is about business logic, which was totally off my radar. It says, it's 3 a.m., I can't sleep due to stress about the status of our instrument. Lack of software support has been a primary reason for where we are today. That is news to me. Possibly you don't recognize how much danger our company is currently in. He then goes on to tell me everyone could be out of a job by Christmas. Awesome. Whatever else you're working on, stop and work on this. So I get this email. I have no idea what the context is. It's entirely blindside, unexpected. I go in the next day and I talk to him, and it's a business logic change. We spent about a year of effort, mainly a 2-man team, occasionally a 3-man, occasionally a 1-man, lots of time and money building the system. And then I was told it has to act a different way. All of a sudden, we have to change how the system acts. We have to change the business logic. And from his point of view, this company is going to sink if I can't do it. Now, because I had designed the software to look like this, and I'll show you kind of how I did it, it took me about 6 hours to go and completely change how the system ran. Didn't touch the UI layer, the resource layer. I changed a little bit about how the business layer functioned. Basically, I had to let the system run in a batching mode so it could collect more data for clinical trials. And 6 hours later, I was a hero, right? I looked tactical, but I was really strategic. So I got that hero recognition. And an example. So if you want to download this, go to gpackage.io /CS car wash. Because I wrote the CLD exam using our frameworks, which is crazy. Pop it over. Okay, so the car wash, the CLD exam, everyone's familiar with this problem, which is why I chose it. Does anybody here not know this problem? I'm going to assume you all do. Basically, they give me this UI. Today's UI day, so I kept it because it's beautiful. And they say, write this application in 4 hours. So what I wanted to do was take this problem and write it with our MBA framework to separate UI and business logic. And I also used our test executive, which is really just like a process framework for executing the business logic implementation. This is where you're going to think I'm nuts. So this is the assembler. This is the guy that composes our solution. It's our top-level BI. If you look at the block diagram, its only job, oops, let me run this one first. Its only job is to compose the parts of the application. So this top layer is a view model. We launched that, and it kind of is in charge of bringing the whole system up for us. Then we have views. So these are the views I created to make the car wash. So I tried to decompose that one monolithic view that NI gives you into several subcomponents. I did that for extensibility, right? So now it's super easy, and I'll show you in a second, to swap one view for another and not change anything but which object it's wired up. Down here we have our models. This is the business logic. So to me, a model maps out you have business logic. All of these models are specific to what a car wash is. And there is a resource as well. Just skip the resource. I might have only put it over here. I only created one resource because they don't give you any, right? It's a contrived example. So I created a fan controller for the blower and stuck it in. So let's run it. Actually, you know what? Let me show you the class diagram. This is what all of our code looks like too. Exactly. Like if you look at any of my customer code, it looks just like this. This is the class hierarchy for a car wash. Right? So do you all think I'm insane?
Yeah. Part of this is your framework.
Thank you. Yeah, so part's the framework. Probably 90% is the framework, the frameworks. So I'm leveraging pretty much all of these classes and just extending it where my application needs it. The only classes that I wrote, you see on the assembler, right? These are the ones that I created from application. Everything else is frameworks that I just take advantage of. So there's a lot of complexity I'm taking advantage of there. If we give this thing a run, it functions. So it brings it up. I kept all these things. Do a few of these. Hit start. Slide the thing. Stop it. All that stuff. Bring it down. So let me just show you the extensions we want to talk about. So we can talk about views. we can talk about models, we can talk about the process model. So the process model is the thing that allows me to change my business logic very, very easily. And I'll show you that in a sec. Let me do this quick. So if I want to change the way that the views function, the way that I designed it was with a view definition class that basically defined what it means to be each of these view components and how they act. And let me run this to show you the view, and then I'll show you what one of these looks like so you get a feel for it. So by doing this, we can just go and skin our UI in effect and make it look beautiful. Oh, it's so cool. I didn't spend a lot of time on it, but it is UI day, so I did a little. So what does this look like from a development point of view? Go to the project. So also notice where the project's laid out. This is pretty typical. I've got my models. These are the models I created, my views, and my resources. I just have the one pan controller. What's the distinction? Let me go here. What's the distinction between a resource and a model? That's an interesting conversation to have. So looking at what we have available to us on this UI, how would we start to decompose this problem? We're going to skip views because that's pretty easy. What are the models? What models should I create to represent the business logic of the car wash based on what we see here? Anybody have thoughts they would throw up? You guys see that at all?
Is it stateless?
So it is stateless. I don't have any big data structures floating around. I've got a sequencer that will sequence different test steps. So each of them, let me see if I have a laser pointer here. I do. So I went and I made each one of these stations a model of sorts. I broke that down into this is an action that a car wash has to perform. So I'm going to take this idea, I'm going to turn it into a process step. So under body wash is a process step, air dry is a process step. What about these ideas of stations? Is the idea of a station something that I want to bring into my design as a model? Is it something that looks like it should be a model but really shouldn't? I'll tell you the decision I made, but I'm curious what you guys think. So, no one wants to talk, I understand.
Well, it's a hard thing to evaluate when we don't know all of the framework parts. Like, what makes an appropriate model?
So, in my mind,
It's more of an approach question, not of the framework.
That too.
a model, think of a model as just implementing business logic. So I'm asking, should I make a station part of the business logic that defines how a car wash functions?
It's a resource.
So resource, so a station is kind of a grouping of hardware in my mind. But if we think of this as, so the way I thought about the problem was what's likely to change or what could change? How do I want to support change in this application? One thing I thought immediately was air dry. Whenever you see air dry, it's usually at the exit. So what if we decided that the air dry should not be part of station 3, but should be at the exit? Can I support that in my software in a simple way? Does grouping things by station make it fragile and harder to change? Do I really care about this idea of the station? Or from the software point of view, is the station really just a UI element? Do the things that make up do the hardware components, the resources, need to know that they're in station 1 or 2? I don't think that they do. I think that if you try to make them aware of what station they're a part of, it ends up making the system more fragile. That's where I landed with it. So I kind of ignored this idea of stations, and I kept this idea down here of options. And to me, the options represent the majority of the business logic and what the system can do with the resources. Now, the resources are implied, they're not given to us. Like I mentioned, I made a fan controller for air dry. You could easily think about different fluidics and motion components that you'd have to have in the system to make it work. Another thing we're talking about, and if you saw Ethan's presentation yesterday, was resource management. What should be an actor, what can just be a wrapper around just a straight class, or maybe a by-reference wrapper for an actor. There's a lot of thought you have to put into this, and it comes down to, do I need to interact with my resources synchronously or asynchronously? I decided that most of these, or all these resources, the one I created, the air dry system, would probably just be a serial interaction, where I want to go and turn the fans on, go do some stuff, and then when it's time, turn the fans off. So I don't need that to be an actor. I don't need to make that a model. I can just have this resource component that goes into my main model and gets used by things.
Yeah, but that's until your requirements change and you're required to pipeline multiple cars inside the car. Then different stations need to work at the same time.
That's an interesting thought. Have you ever seen a car wash work that way?
No.
Um, I still think that's okay, right? Because these are at a certain place in the car wash, there's no reason they can't work in parallel together. That's okay.
Yeah, we're LabVIEW developers, we do it all the time, like mining.
Yeah. Yeah, I don't see that as being something I've coded myself into a corner for. But sometimes you do need to have an asynchronous resource that can be doing lots of things at once. And so sometimes you do need that power of making it a more formal actor. That's kind of how I started to decompose this in my head. I ended up making a view component here, a view here, but I broke this view up into 3 components. So in the MBA, we have this idea of a view manager, which lets you embed subpanels into a view. So I have a view for the wash entry, for this, and for this. And I made this into a component as well. You can see a little block diagram. For models, I ended up with these. Let me show you. So for views, if we just pick one, view console. I created this definition. This definition kind of defines what it means to be an entry console, what I expect of people that extend this. And so I put it in charge of registering for different events and messaging. These are all MBA constructs, so you've not seen them before, so it's not fair for me to show them to you in such a limited time. But I put that logic up in the definition of what this needs to do, so that the extensions are really, really simple. All that they need to do is basically define their interface and make the references available to the definition class. So you can just easily make these little UI widgets that just do their job. This is where I can give this little component to somebody who's not as familiar with this style of programming, who may be more tactical minded, and say, I've created this for you, go here and make the UI for me. And just obey these rules, and it's just going to plug in and work. I can just load it and it's going to run. So all the views are written this way. On the model side, the majority of my models are what I call process models, and these define process steps. These are basically mapping to different options. And I want to be able to string these together using a sequencer. Who here has written a sequencer 1 million times? Everybody, right? Who here just uses test stand for sequencing? Some people do. And your customers are okay with that. I don't know if So I've written it so many times, we've all written it so many times, I just made a reusable component as a framework for sequencing. And I wrote it in a way that the sequencing bit doesn't know about what it's sequencing, so it's completely decoupled from the domain-specific application. So you can just sequence whatever you want. So you end up creating basically a suite of things that your system can do, and this will map to the business logic. And then the sequencer's job is to go and make these run in a certain order. And the sequencer also has the ability to implement flow controls. You can have looping and case structures, you can declare variables and pass them down, you can introduce subroutines, so you can break them up by functionality like you would a sub-PI, save it to disk, load it, all sorts of crazy stuff in there. But it's a little component you can just use in your application and get this stuff for free. So this is in here. If we look at the process model, this is the part that you have to write. So I gave you the sequencing bit, but it's your job to write the process model, because the process model defines how the sequencer runs, and that tends to be application specific. This is the meat and potatoes of what's happening. So the only thing you really need to consume is this one method for the process executive, for the sequencer. It will go and it will basically spit out the thing that you need to do. It's kind of just a thing doer. We're trying to think of a better name for it. So thing doer is on the table. In my case, I wanted it to sequence objects. So I can define that. I can pass in objects. I don't care what the objects are. Objects come out. I inject what I want into the object, so some attributes so that it can actually run. And then I go and I run the thing. It's just it's a model, right? Each of my process steps is a model, so the MBA framework can launch my model for me, and then I just ask it to go and run. And so I've now got a business logic runner that separates out the concerns from the UI, but it's just a sequence. If I need to change this, it's super easy. So let me go over here. So this is an extension. You notice that I added a chunk of code up here. I added in a couple of view managers so I can stack more components up. And then I also added a few models to make things work. If we go and run this, it's going to look a little bit different. So I put a splash screen on as one of the viewable components. And then I added this navigation pane on the left. This is all the same, right? I didn't touch any of this code. None of the views over here were touched. I just built this in and stuck it into the main application. If I go over here to the process builder, we get this little tree control. And this is another shipping component. So it's another G package you can download that extends the test executive and gives you a UI element to go and build sequences. And this is just a drag and drop editor. You can right click and you can insert looping, subroutines, conditionals, and also your business logic for how you want it to act. So in this case, I've got a $10 option. If I go back to the car wash section and I hit $10 option, it's going to just go and run that subroutine. And it's done. If we go here, I don't think I have time to build another one, but this is just persisted as an XML file on disk. And what ends up happening is our customers end up writing more code through this user interface than they do with LabVIEW. So we've kind of abstracted the need to write LabVIEW away from the customers. So we can use this technology stack on these projects, and my customers end up with thousands of XML files that they can go and they can maintain and write. So they completely change how their system runs without having to recompile LabVIEW. So it's like a little scripting language that allows them to change their business logic all on their own. And that's part of how I was able to do that thing in 6 hours, was we just go and we write some more sequences, not to do anything else. And it just works and everything's happy. Got 9 minutes left. Any questions? We've just kind of been plowing through it.
So how long did it take you to write the solution to the CLD?
Oh, this solution?
Yeah.
I did it at night, a few nights. I bet you probably 10 hours.
So you would have failed.
Oh, yeah. But also, I wouldn't hire somebody that would pass the CLD just being technical, right? That's what we care about.
Yeah.
He wouldn't have failed. He did the full implementation. In the CLA exam, he would have just written instructions for his CLD on what to implement.
Okay. Well, he said CLD exam, so doesn't CLD have to work?
Oh,
Yes,
yes.
CLD has to work.
Oh, yeah.
This is also CLA. This is a CLA exam too.
Oh, okay, cool. I'm just kidding.
But no, it's a good point, right? And that's a valid point. That's kind of what I was saying before, is the CLD anything more than a stamp on the forehead saying that you were in pain for 4 hours?
It says that you were willing to see it for
Yeah.
4 hours and go to that page.
Yeah.
That's how much I care about my news. At least I have that bar there. Yeah.
How long did it take you to write the framework?
Oh, the framework? So it's a couple frameworks that you're seeing here, and it's been years of development for both frameworks.
Continuous.
Continuous,
Just
yeah.
kidding.
No, like not constant, but yes, we're always working on it.
Okay, and one thing I didn't see is, I didn't see any templates that you used
Yep.
for, you have templates in there?
No, we don't have a lot of tooling around it, which is why probably nobody but us is using it, even though it's all open source. Yeah, we have to make money too. But if you want to contribute, please come and make templates for us. It's open source. Yeah, so we should, and we know this. We know that we need better examples, better documentation, templates to make it easier, some scripting stuff. Yes, we need these things. But for the time being, our customers want to pay us to make their stuff work. And if this is open source, if anybody gains interest in it, then yes, let's work together to make this stuff easier if we work as a team. So if you want to play with this, go to G Package Manager, pull it down. G Package Manager installs the dependencies alongside the project, so we're not going to pollute your VI-lib with any of our frameworks that you may not want to use. Maybe you do. If you do want to use it, go back to G Package Manager and apply our frameworks to your project. There you go. Perfect solution. So I have a few more slides. I'm going to jump out of code unless you have any code questions. And if you're interested, talk to me or play with it. So that's where it is again, if you're interested. Bitbucket if you want the source, you want to go fork it or something, and then Gpack you just want to go see it. So, one thing I thought would come up is, this is crazy. So am I being reasonable? Is it fair to expect everyone to write their code this way? Is our tech stack too hard to learn? Possible to apply these ideas if you've established code base, other things. I firmly believe that saying we can't adopt this because our people don't know it is a terrible reason not to adopt it. There's really no other place in your life where you would say, this tool is perfect, but I don't want to use it because it's hard to learn. I don't see anyone making that argument. And to back it up, we have worked with customers, like I said, who don't know much about LabVIEW and come in, and we've taught them how to work within our frameworks and then be able to extend them themselves. Once you get the idea of, I want to build a model, I want to build a view, this is how it works in the assembler, it's really not that difficult to extend an application. It's a different ballgame to set the application up that takes some experience. So that's just life. This is a book that I read called Talent is Overrated. It talks about this idea of everybody really has the same opportunity to learn the same skill sets. It's just a matter of application. So I don't buy it if you say that this is too hard for me to learn.
I do have a question. So I've heard you. I've heard you say that you guys give this framework to your customers and let them mess around it. How do you prevent them from making real messes? Like, how do you sandbox them? Because obviously, like, there has to be, is there like a set of rules that they have to follow? Because, like, I mean, I imagine they could do something that would somehow break or mess up the framework. How do you prevent that? Or
Can't really mess. The framework is a black box, right? They don't mess up the framework.
well, no, but I mean, there's certain rules for plugging into the framework, right? Like like.
Yeah, no, there
They can
are.
plug anything they want in. So, I mean, how do you communicate that? How do you, and do you get callbacks from people who insert, do stuff with the framework that it just either doesn't allow or like doesn't follow the rules for plugging into the framework?
So typically, the way we engage is we work on the project with the customer. So they're with us, they're part of our team. We do sprints. We bring them into the sprint team. And they get that experience by working with us on how to use the framework. Right now, I'm kind of embedded in the company. When I got there, the guy didn't know object orientation or active framework. And now he's a master at this stuff. Like, I want to hire him for Compose Systems because he is so good at using our tools. Actually, I put him as an author on the test executive because he and I working together, we've done some cool stuff with it. So we haven't had that problem yet because we were able to work with the customer. We don't just give it to them and walk away. We develop it with them. They know how to use it.
So other question though, like people who you bring on like that, then because the framework's so abstracted, do they just know how to do your framework, or at the end, do they actually know how to do like write their own actors and stuff as well, or are they just learning to plug into the framework?
Why would they want to write actors without the framework once they know how to use it?
Well, I guess when you have a really good hammer, everything looks like an nail. But.
So I was hoping somebody would say that. I also hate that people call it an hammer, the golden hammer anti-pattern. What is a hammer? Is LabVIEW a hammer? You know, like we all use LabVIEW. Is that the golden hammer for? To me, if the problem domain is similar enough, it's perfectly reasonable to use the same solution, the same frameworks. I don't see that as being a valid argument for what we do. We don't do the same thing everybody in this room does, so different contexts.
And there's nothing domain specific about any of the tools that John
No,
showed.
exactly. It's all easy decoupled.
No, yeah. You're welcome.
Chris.
I busted your chops.
Yeah, no, I busted his earlier, so.
It's slightly off topic, but you said you took someone who had very little LabVIEW experience or none and pulled them into this framework. How on earth did you do that? Are there existing resources or?
It's better that way, actually. If you know LabVIEW and you come into this, you're like, this doesn't make sense. If you don't know LabVIEW and you come into this, you're like, I need to do these things to make something work.
I agree with that completely, but I do not know any resources to start with advanced OOP concepts and use that as a starting point.
I'm the resource, Ethan's the resource. That's the problem, is we're the resource. We're there with the person.
Okay.
I don't believe that you can give somebody a book and say, read this, and it'll be as good at your job as I am at mine. You need to work with people who are masters of the domain. It's just how it is.
I agree, but colleges use textbooks still.
Well,
even though
also
they have a
first-
teacher.
We don't separate concerns to make things harder, we make it easier, right? So the framework sounds abstract and difficult to understand, but when you understand the boxes you're implementing in, which we can easily teach someone, suddenly they don't have to think about swarms of actors and message coupling and all this other stuff. There's a lot you don't need to know.
So I guess phrased another way, when people are done, are they master? This is kind of what Sam asked. I think could they do general OOP? Like, do they understand general concepts, or are they masters of your framework?
So I'll give you two examples. I'll call them Tim and Alex because that's their names. And you'll Tim is now extremely competent with object-oriented design, and that's all from working with us over the last year and a half. Alex, who is less software-minded, he doesn't because he has to. Tim loves it. Like Tim just dove right in. Alex is more of he's able to use our tool chain to be successful, but he probably wouldn't want to go and design something from scratch that didn't use our tools. So I like to just say to people like Alex, we've abstracted a lot of what you have to know to be successful with LabVIEW away from you. And now you're not learning LabVIEW, you're learning our tool chain to be successful. And that's the value they care about. They don't care about getting to LabVIEW, they care about making money for their company, right? That's what they want. So it's been okay so far. Jeremy, out of time? All right. That's the end.